Chapter 9, Geometric Figures, Lesson 5, Cross-Sections. The essential question for the chapter: how does geometry help us to describe real-world objects? Again, we're in Lesson 5, the last lesson in the chapter, Cross-Sections, and we're going to focus on the third objective, describing the two-dimensional figure that can result from slicing a three-dimensional figure. Vocabulary: prism, bases, pyramid, plane, coplanar, parallel, polyhedron, edge, face, vertex, diagonal, cylinder, cone, cross-section. Identifying a cross-section. A cross-section is the intersection of a solid and a plane. In other words, what two-dimensional figure will you get when you cut this slice? Now, to help us with this video, we have a special guest, and here he is.
All right, my name is Mr. Kelly. I'm an 8th grade math teacher here at Albert Leonard.
Fantastic. And what are you going to do for us today?
So I want to show you some cross-sections of some different shapes, three-dimensional objects. Today we're looking at different three-dimensional objects and what their cross-sections look like. Here we have an orange, which is roughly spherical. It's not a perfect sphere, but we're going to treat it as such. So when we take the cross-section of a sphere, we cut carefully directly through. Okay. And you can imagine now, what do you think that cross-section looks like? And if you imagined correctly, you will see a nearly perfect circle. And as a visual, if we place the plane through the three-dimensional object, you can see we can recreate our sphere looking just like this, where each cross-section is a circle. Alright, and here we have a rectangular prism. We're going to take a cross-section of this. I'm just going to spin it so you can see what we're looking at here. Alright, and we're going to take a cross-section of this nice and slowly so as not to get injured, going horizontally through it. Again, be very careful, especially when the knife edge approaches your fingers. And it'll get roughly a little bit smushed, but you'll get the idea. As soon as we open it up, you'll see that the cross-section of it is two rectangles. See a rectangle on each side. Now we'll put the plane in between them, and you'll see, again, putting them back together, that is the cross-section of a rectangular prism, just like that, moving at different angles. And there you go. Taking them apart again, you'll see two rectangles formed from the cross-section of a rectangular prism. Okay, so back to this rectangular prism. We've already taken one cross-section, but we put it back together, so it's back to a no, it's not regular. It's a rectangular prism. Okay, now we'll take a cross-section of a corner here. So I'm going to slice at an angle through, and I'm trying to predict what that shape will look like once we cut through. Again, this is some sort of awesome Play-Doh, so it won't be perfect. But as you look carefully at the image formed, this is roughly a triangle right here. Again, I smushed the top a little bit, but you can certainly see a side here, a side on the bottom, and a side on that edge. Now, when you put it back together, so this is...
Now, this didn't come to look like a triangle just because it's smushy, but on this object it would have been too.
Here is your diagonal cross-section, here, from this angle. And again, if you were to trace it, you'd have one side here, and one side here, forming a triangle. So here we have a square pyramid, called a square pyramid because the base is a square. Again, it's not perfect. We're dealing with a real life situation here. So we're assuming this is a square with right angles, and it's a pyramid. All right. What happens when we do a vertical cross section of it? Well, we'll cut through and we'll see. Going straight down. Now, you're making your prediction right now what shape we're going to envision, and if you guessed that we're looking at a triangle, well then kudos to you. Nice job. Again, one edge here, an edge along the bottom, and an edge along that side. Let's put it together with its buddy here and actually envision what this looks like. So there's our cross section. There's our plane going right through it.
And again, that's how it's going to look in a word problem.
Going through, and again, here you see your two triangles. Looking at a square pyramid, again, we just did a vertical cross section. Now we're going to do one parallel to the ground. So if you see this is the plane, I'm going to cut right through parallel to it straight across horizontally. Now let's see what kind of shape we're going to get here. Again, you're going to be making your prediction. And we might have to use our imagination because, as you can see, it's not going to go perfect, but you should get a good sense of what this cross-section will look like. Carefully, carefully, be careful. Don't cut yourself. Alright, now we open it up, and boom, hey, look at that. That's not bad, okay? Looking at its edges, you should see, again, it's a little rough approximation, but you should see 4 equal edges, and sure enough, the cross-section horizontally of a square pyramid is indeed a square here and here. Let's put that plane in and take a look at it. Here and here and here. And again, you see the cross-section of a square pyramid is 2 squares. Alright, we're looking at a square pyramid here. We've already done a vertical and a horizontal one, so you should remember what those look like. But now we're going to get a little bit more interesting and actually cut at an angle. I'm going to put the plane here so you'll see. This is the incision we're going to be making, diagonally down through it. Alright, so we'll start here, cutting in at an angle. And you're predicting what this is going to look like. You can see one edge there. But when we put it together, you'll see, and I'll narrate this a little bit. You'll see a top edge. Now there's 2 edges coming down on the side and 1 across the bottom. So if you guessed that this would be an isosceles trapezoid, well done. Again, looking here, you can see we've got a bottom edge, 2 edges that are congruent, that are your the sides of the isosceles trapezoid, and 1 across the top. If we gently take this, insert the plane where the incision was made, and put it back together, you'll see our square pyramid has been cut with a cross section, creating 2 isosceles trapezoids.
Mr. Kelly, thank you very much for your help, and this was fantastic, and they got a great year for looking forward to being with you next year.
Absolutely. I hope I get to teach each one of you guys. Thanks for paying attention.
To explore this topic more, you can go to this great website. It shows you the cross sections visually. I'll give you a little sample of it. Here I selected a pyramid, and I have a cross section here. This is where the plane would cut it, and here's the cross section on this side. And you can see as I move it up and down, you can see that the cross section becomes bigger, because that's what would happen as you go nearer and nearer towards the base. I can change the angle. So here you'll notice that it looks like a triangle when I cut it that way. And here's the cross section there. If I go like this, you can see what kind of shape it would create. So very visual, very helpful in seeing what's going on. Move this a little bit more. I can also move this one. And you can see the type of shape it's forming. As Mr. Kelly showed you before, when you cut it at an angle like this, not parallel to the ground, or horizontally, in other words, or vertically, it's going to look like a trapezoid. So I hope this video has helped, and thanks, Mr. Kelly. It was great working with you.